Problems from Chapter 4.
Here comes some problems from Chapter 4. This is from your worksheet. Before I do, I'm going to pull out the little rules of exponents here in case I have to use any of them. It's right down there in the bottom left of your screen. So here we go. Right here I have something. I'm going to try to get rid of these parentheses here so I can flip this guy, have a division problem, then multiply across, simplify. Let's take a look here. I have this guy raised to a power. That's similar to rule. Do I have something? Oh, look at this. Raised to a power. What do? Multiply the exponents. This is 6 to the 1, so I'm going to take care of this guy here. See this guy right here? I'm going to rewrite it right here, take care of business. Flip it and multiply by this. Because this guy divided by this is the same thing as this, flipped, multiplied. So watch what I do. This is 6 to the 1, 8 to the 1. You don't see it. This is 3 to the 1. So let's see. 1 times 2. 2. 1 times 2. 2. 3 times 2. 6. 3 times 1. 3. 5 times 3. 15. 2 times 3. 6. Now I'm dividing by this, which means I have to flip it and multiply, so I'm going to rewrite it here. 6a4, b8, 9a5, b. Now I'm not going to multiply this 3 out because I'm going to be able to reduce it later on, you'll see. Alright, 3, let's see, that's a 6, 2. Okay, I flip it around, I end up with 3, a15, b6 on the top, 6, 2, a2, b6. Now I'm going to multiply across. I'm going to multiply now. I'm not raising to a power. That's rule 1. When I multiply the same base, add the exponents. A and A have the same base, right? 6 and 3 don't, so I'm going to write it like this. 6 times 3 cubed. Now A4, A15, A19. B8, B16, I'm adding the 8 and the 16 because I'm doing this here. B14. Ooh, look at that. All over 9 times 6 squared. A5, A2 is A7, B1, B6, B7. Now I'm going to look for canceling out. Well, let's see. My 6 in this 6 squared is a 6 times 6, so I'm going to get rid of one of the 6's here, so there's just 1 6 left in the bottom. Now I know this is 3 times 3 times 3. Well, if I write this out, 3 times 3 times 3, two of them, 3 times 3 is 9, that cancels out with this. Now I have 3 and a 6, this guy's gone. This guy becomes a 2. Now I look. I have a 2 in the bottom. What happens with these guys? Well, isn't this the same thing as this divided by this? Yeah, it looks like this form, doesn't it? So when I have AM over AN, I can just subtract them. So let's see. I've got a 1 here and a left over up here. So I have 1 half. Now I do 19 minus 7, A, 12, 14 minus 7, B, 7. And there's my answer. This can also be written as A12, B7 over 2. Another way to write it. Okay? Because what happens is if I have 19 and 7, right? If I have 19 A's, I have 19 of them, and I have 7 of them down here, right? These 7 cancel out 7 of these guys. There's going to be 12 left over on top because 7 of them are canceled out. Same thing with the B's, all right? That's how these rules work. We talked about that in the last section. All right, so now we're going to stop moving and move a little bit quicker, okay, using these rules. 19, I'm saying, what can I multiply by negative 2a cubed b to the 4th to get 8a to the 6b 10? All right? So I'm looking at this guy. I'm like, all right, well, I need to get a positive a to have a negative 2, which means I need to multiply it by a negative 4. Negative 4 times negative 2 gives me the 8. Now, a to the 3 times what? I need to multiply something times a to the 3 to get a to the 6. Well, I know I'm dealing with this right here, adding the exponent. So I need an exponent that will add, so a to the 3. 3 plus 2 would give me that 6. Same thing. B, I gotta get to the 10, B4. B4, oh, sorry, no, B6. B6 plus B4 is B10. A3, good. When I multiply, because what do I have here? When you think about it, I have A. Over here I have A. Altogether 6 A's. I have 6 B's, here's 4 more, 10 B's. Okay, fill in the blank. Alright, this one. What rules am I using here? Well, I have raised to a power. It's right outside. So I multiply 2 times this thing. So I end up with Q times 2 times this, right? 2 times that is 2y minus 14. On the bottom I have a Q. 2 times this guy. 2y plus 4. Now I have this divided by this. It looks like this, doesn't it? M minus n. So I'm going to have Q. That's my M. So 2y minus 14 minus my n, which is down here. This will be my n. 2y plus 4. It ends up being q 2y minus 14 minus 2y minus 4. Look at my like terms. These are all in the exponent. Q, 2y minus 2y, they cancel out. Negative 14, negative 4 is negative 18. Now look at this. That's like rule number 4. A to the negative m is 1 over it. So I can rewrite this as 1 over q to the 18th. Alright, next problem. 32. Let's take a look at it. Alright, I'm doing the same kind of thing, right? Here we go. I'm raising everything here to the 2n plus 1, but be careful. I don't know if this is odd or even, and this is a negative 1 out here. So I have to raise that negative 1 to the 2n plus 1 also. That's like the tricky part of this problem. So I'm going to put a negative 1 there. Now watch. I have negative 1 to the 2n plus 1. X also. These are all to the 1, to the 1, to the 1. Remember, I'm multiplying. I'm dealing with this. I have something raised to a power, so I multiply the exponents. 1 to the 2n, 2n plus 1. Y, 2n plus 1. On the bottom, x to the 2n, y to the n plus 1. Now, I have these things are dividing. I have x over x, right? I can break this up as like this over this times this, this. It's like I can look at just this part right here, this division and this division. So I have it looking like this, same base. I have to do m minus n. So I have to do this minus this, right? So that's how it's going to look. So I'm going to have negative 1 to the 2n plus 1. Now, I have to do this minus this. So 2n plus 1 minus 2n just gives me 1. X to the 1. Now I'm doing 2n plus 1 minus n plus 1. So just to be careful, I'm subtracting this whole thing. I'm doing 2n plus 1 minus all of this, n plus 1. So I'm subtracting the n and the 1. 2n minus n gives me n. And 1 minus 1 gets rid of it, right? The 1 minus 1. So here's what I end up with. Negative 1 to the 2n plus 1, x, y to the n. Alright? Should have taken that 1 out there to make this have made it a little bit more difficult than it should have been, but here it is. Here's your problem. Very nice. Next! Here's a nice simple one. 2x over x squared times, flip it, x to the negative 3 over 1. When I multiply like bases, I'm going to multiply the top to get the top. 2 times 1, I get 2. X to the 1 to 3, what do? Add, right? X times x, they both have the same base. 1 and negative 3 is x to the negative 2. Very nice. X squared times 1 gives me x squared. Now what do I have to do? Well, I have the same base over it. So that looks like this, m minus n. So I have to do negative 2 minus 2. Oh my goodness. So I get 2x, negative 2 minus 2, negative 4. You could also write it as 2 times 1 over x to the 4th, which is the same thing as 2 over x to the 4th. Okay? Alright, here we go. Can we get to the next problem? Good, I have enough time to do one more problem. I'll do a couple more. Next one. Alright, this is just a distribution problem, but notice I have this 2 here. I can't make, now look at, I can't because this is a sum in here. These rules, this guy's attached out here. This will work for things that look like this. A squared x to the 3rd squared, right? I can do 2 times 2, 2 times 3. But right when I get a problem that looks like this, a squared x to the 3rd plus x squared squared. Now I can't do this. There's a sum in here. This has to do with products, just all multiplication. I can use these rules. Here I have a sum. Now what do? Well, I know what this means. It means 2 of these things, so I write it out like that. Times x squared minus 3x minus 3. So, just like when you multiply numbers, 4 times 3 times 2, you multiply these guys first, get 12, then multiply it by 2, right? 24. Same thing here, multiply these guys first, then multiply it by here. How do I multiply?